Hello everyone, I'm Chini Ambarunday and today we're going to discuss about octal to binary, octal to decimal, and octal to hexadecimal. Let's focus on octal to binary. Octal numbers use a base 8 system, meaning each digit can range from 0 to 7. Binary numbers, on the other hand, use a base 2 system where each digit can be either 0 or 1. Here we have our sample 345 as our octal number, and we're going to find its binary equivalent. First, let's start with digit number or with the first digit, which is 3. So as you can see, below number 3, you can see here 421. So let's start with the on the right side, which is 1. 1 is equivalent to 2 to the power of 0. Why we use 2? It's because of the binary base number, which is 2. So 2 to the power of 0 is equals to 1. 2 to the power of 1 is equals to 2. And 2 to the power of 2 is equals to 4. Since we're just looking for 3, we must not exceed more than 3. So we will just stop here at 4. We will not proceed more anymore at 2 to the power of 3, which would be more than number 3. So 4, if we're going to find the first digit for octal number, we're going to find its sum. So we put here 0 below number 4 because it exceeds number 3. Now, as you can see here in number 2, we gave a value. So let's put here 1. Why? It's because 2 is can be added with 1. So if we're going to sum these two numbers, 2 plus 1 is equals to 3. So we will put here value for each number. So there will be 1 under number 2 and 1 under number 1. So the first binary numbers for the first digit is 011. So 3 in octal is 011 in binary. Now let's proceed to 4. Convert it. Let's convert the second octal digit to its binary equivalent. So again, let's do the same process. 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4. So since we're looking for number 4, we will put value under 4, which is 1, and the rest will be 0. So 4 in octal is 100 in binary. Now let's do the same process on the third digit, which is 5. The same 1, 2, and 4. So let's put a value under 4. Let's put here 1. And for 2, it's 0 because if you're going to add 4 and 2, it will be 6, which is more than 5. And if we're going to add 4 plus 1 is equals to 5. So we will just put 1 here under 1 and under number 4. And we will put under number 2, 0. So 5 in octal is 101 in binary. So the binary equivalent of 348 is 011100101. So here's the result. That is the binary equivalent of octal number, which is 345. Group the binary equivalents together and the octal number 345 becomes 011100101 in binary. Since each octal digit converts to a three-digit binary number, we don't need to pad in this case because it's been already uh, grouped based on each digit. So now let's proceed to the next topic, which is octal to decimal. Octal numbers are based on powers of 8, and decimal numbers are based on powers of 10. To convert from octal to decimal, you simply need to multiply each digit of the octal number by the corresponding power of 8 and then add up the results. So here let's use again 345 for the octal number, and let's find its decimal equivalent. First, here we are going to start at the last digit, which is 5. Yes, this is different from the binary. So 5, as what I have said, that this one is equivalent to, this time we will use the 8 base system. So 8 to the power of 0 is 1. So let's multiply it to the first digit, which is 5. 5 times 1 is equals to 5. Now let's proceed to the second number, which is 4. So let's use here 8 to the power of 1, which is 8. 4 times 8 is equals to 32. Now let's proceed to the first digit, which is 3. And let's use here 8 to the power of 2, which is equivalent to 64. So 3 times 64 is equals to 192. So if we're going to sum up all the results, 192 plus 32 plus 5 is equals to 229. So the octal number of 345 is equivalent to the decimal number 229. So that's how we find the decimal equivalent of an octal number. Now let's proceed to octal to hexadecimal. Octal numbers are base 8 and hexadecimal numbers are base 16. To convert from octal to hexadecimal, we first convert the octal number to binary and then group the binary digits into sets of 4 to represent each hexadecimal digit. So here, first we need to find its binary equivalent before we find the hexadecimal. So let's proceed to the first digit, which is 1. And here, since we are looking for the binary equivalent, we will use 2. 2 to the power of 0 is equals to 1. 2 to the power of 1 is equals to 2. 2 to the power of 2 is equals to 4. 1, 2, 4. And as you can see, we did the same process to the other digits. So we will just put value for each number that is equivalent to the octal digit. Since we are looking for number 1, 4 will be 0, 2 will be 0, and we will put value in 1 because 1 is equivalent to 1. So 001 is the binary equivalent of octal digit, which is 1. For the second digit, we will put value for number 4, 1. For the rest of the numbers will be 0. Next, for 3, we will put 0 under 4 because it exceeds 3. And for 2 and 1, we will put value for each number, since if we're going to sum up 2 plus 1 is equals to 3. And for 2, here the same, we will put 0 for 4 and 0 for 1. And for 2, we will put a value, since it's the same, equivalent with 2. So these are the binary equivalent for each octal number. Cats. Group the binary digits into sets of 4. So again, we have 001100011010. Convert each group of 4 binary digits to hexadecimals. Decimal, rather. So we grouped it. So we group the binary digits into sets of 4. So each group will have 4 binary digits. So here as you can see below the sets of 4 binary digits, we used uh, base 2. Okay, so under it, you can see here 8421, or if we're going to start on the right side, 1248. So 1 is equivalent to 8 to the power of 0, which is 1. I mean, 2 to the power of 0, rather, which is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. Since we are just focusing on digits with value, so we will only choose those numbers with values. So you can see here under 1, the first sets of 4 is 2 and 1. So we were just going to add 2 plus 1 is equals to 3 in the first sets of 4. Now let's proceed to the second group of 4 numbers, which is 0001. We will still use the same uh, number here, which use the binary system, right? 2 to the power of 0 to the power 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. Since there is only one digit or one value here, and under it is 1, we will only put here 1. And for the third sets of 4, third group, 1010, under it is number 8 and number 2. So we will only add 8 and 2, and the rest of the number which doesn't have a value will be excluded. So 8 plus 2 is equals to 10. So for the first group, sets of 4 is equivalent to 3. Second group, sets of 4 is equivalent to 1. And third group, sets of 4 is 10. Now, as you can see here below, 1432 octal number is equivalent to 31A hexadecimal. So its base number numeral system is 16, since hexadecimal, as what I have said here, hexadecimal numbers are based 16. So so for the 10th position will be the alphabet letter, which is A, and the rest of the number from 10 and above will be alphabet letters. So as you can see here, we used letter A since it's 10, because next to number 9 is 10. However, in hexadecimal, it uses alphabetical letters. So 31A16. So that's it for octal to hexadecimal. Thank you for listening. I hope you learned something.